Hi there, Mr. Cooper here. I'm going to be joining with Mr. Godber in setting you some work during this period when we're away from school. Mr. Godber is going to carry on with the pure maths, and I'm going to cover some of the statistics and mechanics that we still have left to do. I thought we'd start today with a little bit of revision. So we're going to look at mean and standard deviation, and particularly making sure we're confident using our calculator to do it. To do this work, you need to have some questions which are on Maths Genie. They are under AS Maths. It's the interpolation and standard deviation page, and I've put a link to it in the description for this video. So if you can load up or print off that sheet first, and then we're able to proceed. Right, so here's a list of numbers. I'm going to use my calculator to calculate the mean and standard deviation, and I'm also going to use it to calculate the median and the interquartile range. So let's go into statistics mode, and I'm just going to enter those values in. There are only 7 of them, so it won't take me a second. I'm also going to sort of model how I would set this out if I was answering this question in an exam. So there we go, I've entered the values. So the first thing we need to do is to tell it that this is just a list of numbers. So I'm going to go to Calc and Set, and I'm just going to make sure that it says, right, this is one variable data, not two variable data, one variable data, and my list of values is in list 1, and their frequencies are 1. There's just one of each of those values. So that's all good. So I'm going to press exit, and then I'm going to go to 1var, and it gives me all the data I need. So you should be familiar with this notation. So here's how I would write down my answer to the question, find the mean and standard deviation. So I know the mean x bar is 25, but I'm going to show some working. I know that to find the mean, I add up all the values and divide by how many values there are. Value is 175, add up total of values is 175, 7 values in case you can't count to 7, and that gives me 25. So I didn't actually do that sum, I just showed my method. Now the standard deviation is a formula that you need to remember. So it's sigma x squared, the sum of all the values squared, minus the mean squared, or that could be written as sigma x squared over n minus the actual calculation of the mean squared. So these two things are the same, aren't they? And I always remember it as the mean of the squares minus the square of the mean. I don't know if that helps. So I'm going to, and the standard deviation I know is 7.23. My calculator has told me that, so I know the answer. I'm just showing a little bit of method here. So here we go. I've got sigma x squared there. It's 4741. And the mean was 25, and it's an exact value. If this was a rounded value, I wouldn't use the rounded value. I'd type in the calculation again, but as it's 25, I'm just going to write that. So this isn't squared because this is already the sum of the values squared, but you do then have to square the mean. And I know what the answer is, it tells me, and I'm going to use my default accuracy, which is 3 sig figs. So I've got the mean, and I've got the standard deviation. Median, 26. Interquartile range is the upper quartile, which this calculator refers to as Q3. Take away the lower quartile, Q1. And that is that. Could I get you to have a go at question 4 on that Maths Genie sheet, which I've put in the description? I'll see you in a minute. Okay, so here are the answers. that you should have got using your calculator, and email me if you are finding that tricky. So that's mcooper@ilfracombe.org.uk. Okay, so let's move on to the next page then, which is a frequency distribution. So this is the data's been tallied up, and I don't know what this is. This X could be the number of sweets in a packet, and this is the number of packets with that number of sweets. So I'm going to now use my calculator to work out the mean and standard deviation of this data. I've got the old data from question 4 in the calculator already, so I need to delete that. So I press that, delete all. Yes, there we go, fresh start. So I'm just going to enter it in. 7, 8, 9, 10, 11, and 5, 7, 11, 6, and 3. Right. If you remember, with frequency distributions, the formulas are slightly different. So back at GCSE, to work out the mean of this data, we did that times that, and we added up that column. I refer to that as XF. So we take that total and divide it by the number of values which we get from that total. Now the calculator will tell us those nice and easily. And then similarly, the standard deviation, you do x squared times f, which gives you sigma x squared f. You divide that by the number of values, sigma f, and again you subtract the mean squared. And the calculator will give us all of these values, but it's a little bit confusing, unfortunately. So let's go, let's move the data along. So I'm going to get back. I need to do this because I'm on the delete screen, so I go there and then there again. So I'm going to go to calc, but now I need to tell it that I have got a frequency distribution entered. So these are my values and these are my frequencies. So I go to set, and I now say, okay, I'm still on one variable data. I've only collected one thing about these sweet packets. So my values are in list 1, but my frequencies are no longer 1. They are in list 2. There we go. And so I exit that and go to 1 var, still 1 var. I know we've got 2 columns entered, but no, this is one variable data. We've just recorded the number of sweets in packets. So I go to 1 var. And this is where it's a little confusing, because the calculator doesn't use sigma xf, it just uses the calculations we used for a single set of values. So if I want to work out the mean, sigma xf is actually sigma x. And sigma f, which is the number of values, well, that's just n32. And that gives me the mean, which is 8.84 to 3 sig figs. Should have done that earlier as well, actually, just say how you've rounded it. And then similarly, the standard deviation, it doesn't use the extra f, so sigma x squared is the value we want. Sigma f is 32. I need to take away the mean squared, but this was a rounded value, so I'm not going to use that. I'm just going to type that in again. Well, I'm not going to have to type it in at all, am I? Because I've already got the answer. This is me just showing my working. And the standard deviation is 1.18. Okay, so if you have a look at your Maths Genie, have a go at question 1, but don't worry about the linear interpolation bit, just do B and C. Now, question 1 is grouped data. So you've got to remember how we deal with grouped data. You're not going to type it in as it's given to you in the table. You're going to have to remember what we do. Have a go, and then I'll show you in just a minute. Okay, so here's how I did question 1. With group data, we use the midpoints of the groups. And did you notice that the last group was twice as wide, so its midpoint was 190? So that's what I entered into my calculator. Those are the values that I got, including a very, very big number here. That's how I showed my method, and this is my mean and standard deviation. And remember, these are only estimated mean and standard deviation because we've done the whole midpoint thing. So finally, do you want to have a look at question 2? Again, we're not going to do the linear interpolation bit today. Just look at B and C, so they ask you for the median using linear interpolation. I can get you just to do the mean and standard deviation of that set of numbers, and then see if you can answer part C, which is about coding. What happens if you take those values and code it in the way they say? Again, I'll show you the answer in just a moment. Okay, so here's the answers you should have got. Don't forget, if you're looking at the Maths Genie answers, they've done median and standard deviation. We're doing mean and standard deviation. So then you've got to read the question carefully, because it says actually this set of data was coded data, and the original data was times. They say that what they did was they took the times, subtracted 20 and divided them by 2, and that gave us these x values here. So if I want to go back from my x values back to the original values, I've got to do the reverse of that. So I've got to multiply by 2 and add 20. So this is x bar and the standard deviation of x. I want t bar, the original mean of the values, and the standard deviation of t. Now this is where you need to remember when you did coding. When we think about the mean, both of these changes will affect the mean. If you double a set of values, the mean gets doubled. If you add 20 to a set of values, the mean gets 20 bigger. So the mean I'm after, the original mean, will be 16.3 times by 2, add 20, so that's 52.6. However, the standard deviation is a measure of the spread of the data, and if you take away 20 or add 20 to a full set of data, it doesn't change the way it's spread. So only this, or only originally that, will have affected the standard deviation. So this is the only thing we need to do. We don't need to add 20, we just need to take our standard deviation and double it. 15.98 to 16.0 when I round it. Now, okay, these are rounded values. I perhaps should have used the exact values, but don't forget we're only estimating the mean and standard deviation anyway, so this level of accuracy is perfectly good, and anyway I've shown my method clearly, so it's not a problem. Good stuff, well done.